Okay, hello everyone. Good. Yes. Yes.
Okay, thank you. It happened to be again. I have to switch off my mic in different places of the system here. I was saying that Rofayda is going to give us Dockerizing AI models for your Flutter app, and I was saying that this year we hope to have a few or many. We don't know. You know that this is funny because we know, but we don't know. GSoC is this way. How many applications, how many contributors we are gonna have doing artificial intelligence projects, and 95% we can say those are gonna be Flutter applications, and if are AI based projects, those will run on our artificial intelligence servers using Dockers. So thank you guys for advising me that my mic was off. And now, Rofayda, it's your turn. You have the stage, so I want to mute myself and you can start your presentation, okay?
Okay.
Thank you.
Hello everyone. I'm Rofayda Bassem, a computer engineering student and GSoC 24 wannabe. Today I'm going to show you how to Dockerize your AI model running in a Flask app or any backend so that you can access it in your Flutter application. This is our agenda for today. First, we will make a comparison between Docker and virtual machine because this topic may be confusing for many of you. Also, we are going to talk about some Docker basic components. There are other many, but for this session, we are going to cover only the basics. And then we are going to apply what we learned in a demo application. First of all, okay, can you see the screen? I will start my presentation by showing the difference between Docker and virtual machine. In the following diagram, this infrastructure represents your physical laptop. The hypervisor is a software layer that enables the creation and management of virtual machines. Um, Maybe all of you have tried Oracle VirtualBox when he made his Liquid Galaxy setup, and on top of it, all your VMs. Each VM includes its own virtual hardware components such as CPU cores, allocated RAM, storage space, and network interfaces, emulated from the guest OS and hypervisor, allowing you to run multiple instances of Ubuntu, for example, without any interference, as you all did in the Liquid Galaxy VM setup. Every guest OS runs as an individual entity from the host system. Hence, we can look at it as independent full-fledged house where we don't share any resources. On the other hand, the Docker containers are executed with the Docker engine rather than the hypervisor. We'll talk later about what is containers in depth in the next slides, but for now, they are smaller than the VMs and enable faster startup with better performance. They are also less isolated and they have a greater compatibility because they share the host kernel. Hence, it looks very similar to a residential flat system where we share resources of the building. But now, what is host kernel? Host kernel refers to the operating system that directly manages the hardware resources of the physical machine, your laptop in this case, that hosts either virtualization or containerization technologies. Each VM emulates a complete hardware environment, including its own OS kernel, but the host kernel interacting with the hypervisor to allocate the resources like CPU, memory, and so on. But in Docker, as we said, they share the host kernel, and his role is to provide essential services and resources to Docker engine, which manages the container. To sum up, here is a quick summary table. As we said, for Docker, all the containers share the same kernel of the host, but for the virtual machine, each VM runs its own operating system. Also, the container doesn't take any time when they get initiated, but the virtual machine, it may take a minute or two when they boot up. And one of the most important points you should know that images are built incrementally on top of another like layers. Also, I will going to explain what are images in Docker, but for now, you should know that the images are built incrementally, and it doesn't happen in case of virtual machines. Also, for Docker, that can be a version control. It's similar to GitHub. For Docker, we have Docker Hub, but for virtual machine, there is no version control. Also, we can run many Docker containers on the same laptop, but for virtual machine, we can maximum run 3, 4, depending on the specifications of your laptop. Finally, multiple Docker containers can be started from one Docker image, but this is not the case also in virtual machines. Now, most of you may wonder which is better, Docker or virtual machine. It depends. The application design is one standpoint suggesting which one of the two should be chosen. So if the application is designed to provide scalability and high availability, then containers are the best choice. Let's get into Docker containers. Here is the 5 main components I'm going to explain in this session. What is Docker client and what is Docker server? Also, what is Docker image, Docker file, Docker registry, Docker containers? We are going to go in details for everyone. First, the Docker container. What is a Docker container? Just imagine you have a laptop with a Docker installed, and you open your terminal window or your CMD, and you type command like docker pull. What is docker pull? We are going to explain it later, but for now, you should know that when you type your command, this command, they are instruction given by you. You are the user, and you give this instruction to the Docker client, and you tell Docker client what to do. Then what is Docker server? The Docker server is also known as Docker daemon. It's a program running in the background on your computer. So after you type docker pull, what happened after that? The Docker daemons start downloading all the images required for the command that you did. And it stored it locally on your laptop. We have Docker client and also we have Docker server. So there should be a communication between both client and server. This communication is done through REST API. This is a protocol used in Docker engine. And finally, we have the Docker host, and this is your laptop or your cloud server that may contain your Docker engine. Next, we have the Docker image. So what is Docker image? We already talked about it in the previous slide. It's now we need to go in detail on what is Docker image. Docker image is a read-only templates that contain all the instruction for creating a container. It's like a snapshot or a blueprint for all the libraries and dependencies required inside a container for an application to run. Next, we have the Docker file, and this is what we are going to write in this session. But for now, you should know that Dockerfile is a text document that contains all the command that a user could call on the command line to assemble an image. Then we have the Docker registry. The Docker registry is like Docker Hub. This is where you store all your image and you can share it with any other people, or you can take other images that some people have shared. And finally, we have the Docker container. The Docker container is a runnable instance of a Docker image. So when you create a container from an image, it becomes live, isolated environment where your application or service can run. So containers are like lightweight, portable, and can be started, stopped, and managed independently from each other. And we are going to see how we can stop and store and initiate a Docker container. For the demo of today, first of all, we are going to get our Gemma model, and then we are going to run this Gemma model in a Flask app. After that, we are going to take this app, write its Docker file, and then we are going to run the container on the server. And here you can access your endpoint from your Flutter application. So let's get started. I'm going to share the screen for the whole. Okay, first of all, we need to get our Gemma model. So we are going to register to Hugging Face. Okay. When you sign in for Hugging Face, you will get, you need to grantee access for every model you are going to use in your code. So I'm already done with the steps, and this is our model. Now we want to write the code. You can find here at Hugging Face, they give you like a snippet on Python, and this is what we are going to do now. So I will open my Google Colab. Okay, I have already the code written here, and I have already run the code. Why I'm running the code here on Colab? Because my laptop doesn't have a good GPU, so I'm taking advantage of the GPU on Google Colab. And here is the code with all the dependencies installed. This model doesn't have any fine tuning. It's just the model as it is. So it maybe takes some time to get executed because it's not fine tuned, neither optimized. But what I want you to see that I tried the model on one time on the CPU and the other time on the GPU to test the time of the execution. When the model is run on the CPU, we have here the time of the execution is 84 seconds. It's 1 minute and a half. But when it's run on the GPU, it's only 13 seconds, so it's more faster. Why I'm showing you this? Because when we are doing our application on Flask application, I'm going to run on the CPU, so it may take some time to execute the command. Okay, let's open our Visual Studio to write the Docker file. But first, I want to show you the Flask app. Here we have a Flask app having two endpoints. The first endpoint is just for testing, to test that the Docker container is running successfully. And the second endpoint, it contains, you just give here the input text and it generates the text for you. Okay. Now let's write our Docker file. As we said, the Docker file is an instruction file that help you to build your own image based on your own requirements. So for now, we have a Flask application running in a Python environment. It has some dependencies that need to be installed. These dependencies are here in requirement.txt. Also, it has an access token that need to be read from another file, as you can't hardcode this access token in the application itself. So you need to pass this access token to the Docker file. So how we can make this? First of all, when you start writing your Docker file, you need first to specify which image you are going to build on. So in our case, we are going to build on Python image. It's an already image that already exists on Docker Hub. You need to take this image and make some changes, install some dependencies based on your requirements. So first thing, we are going to get our Python image. We are going to take version 3.9. To understand more, the base image is like a small operating system that you are going to add all your dependencies on it. So we have here the Python. Then now we have this small bundle called Python. It has no dependencies. It has no program run in it. We need first to install some dependencies for the system. When you started making your Liquid Galaxy virtual machine, when you entered on your VM for the first time on Ubuntu or any Linux distribution, you will need to install some dependencies. You need to update your system. You need to upgrade and install some libraries. So here we have some dependencies that we need to first install for the system. apt.get update and apt-get install. We need to install git and curl, all that stuff. Then imagine yourself, you are now in your virtual machine and you want to run an application. So first thing you do is making a working directory. So we are going to make our working directory and it's called app. Now your working directory is empty. You want to copy all the files to this working directory. So we are going to copy all the file, which is the app.py that having your Flask application and your model running in the Flask application. You need to copy all that into your working directory. So to make this, we only write copy, and we have here the source and the destination. The source is our current directory. So we make only a point or a dot. Next, we have the destination. We already specified that our working directory is here in the app. So our destination is going to be also a dot. Next, we need to install the project dependencies. So imagine you are now on your laptop and you have this repo cloned, and before you start running your application, you need to install all the requirements. So in case of Python, all you do is run, okay, and you make pip install for all the requirements. Okay. If any of you have worked with Flask before, you should know that it has an environment variable called app. What does it mean? It means that when you start your Flask application, it go to app.py and start from this file. So we need to set this environment variable. So we have here env. I have already the code here. I'm going to copy and paste it directly. So now we have our environment variable called Flask app. It's already set to app.py. Then we need to set our environment variable for the access token, because the access token shouldn't be exposed in your own code. It needs to be embedded into your Docker image. So we are going to use this line that read. I will show you what does this line do. First of all, it read the access token from a file called access token.txt, okay, and then set the access token of the transformer to what read from this file. And the last two steps, we need to expose our port. Flask app run on port 5000. So you need to say to your image that it's going to access the port 5000 of your local machine. Finally, we are going to set the entry point for our Flask app. To run your Flask app, yes. It's now the Docker file. It's not shown. Okay. But now we are explaining the Docker file. Okay. We are not able to see the Flask app or the Docker file. Yes, I was writing the Docker file now. It's not visible. It's now visible or no? Uh, it's okay. Okay, now you can see the Visual Studio. Still no? No, I'm showing Visual Studio. It's now shown. Okay. So I think you didn't see anything for the Docker file. So I'm going to re-explain again. I will explain uh, what I was explaining when the screen wasn't visible, that now we want to build our Docker file, okay? Um, I have here a Visual Studio setup, okay? And it has my app.py. This is our Flask application that has two endpoints. The first endpoint is just to test that the app is running successfully. The second endpoint, this is one that you give her the input text that you want to give it to your model, and it generates the output for you. So it's a very, very simple Flask application with two endpoints. So now we want to make our Docker file. So to make our Docker file, first thing we need to do is, I was writing this before the screen was visible. So I'm going to explain it, what I wrote again. First of all, we are going to pick our base image. What is a base image? This is the initial startup of your application. Your application run in Python environment, so you need to get a Python environment that already set for you. This image is on Docker Hub, so you can simply pull this image and use it. But you need to adjust this image based on your requirements and your application. So after you got your base image, imagine you are now in your virtual machine, but it's not a virtual machine, but imagine with me just to understand this line. So you are now in your virtual machine for the first time. first thing you do, you need to install some system dependencies. For example, you need to apt get install, you need to install git, you need to install curl, you need to remove some old files from your system. So this is what this line do. And next, you have your system. It's clean now, but it doesn't contain your application. So you need first to make a working directory where you are going to copy all your files of your application. So here I have set a working directory. It's called app, and now we are in the directory of the app. But it doesn't contain our code or our Flask app or our requirement.txt. It doesn't contain anything. So we need to copy these files from our system or from our current directory to the directory of our image. So how to make this? Just make a copy. The first parameter is the source, and the source is the current directory, so we make a dot. And the destination is also the working directory of the image, which is the app, and this is why we have made also a dot. Now we have our base image that have all the system dependencies installed, and we also have our working directory, and in our working directory we have all our files. So imagine now you have all this. To run your application, you need first to install the project dependencies, and these dependencies is already in the requirement.txt that we have copied before. The requirement.txt has all the libraries that you are going to use to run your Flask and your Gemma model. So this is what we are going to run. Next, we need to set some environment variable related to the Flask application. If any of you have worked with Flask, you need to set a working environment called a Flask app to be equal to app.py to understand that this is our entry point to our application. So we are done with setting the environment variable for Flask. Next, we need to also pass our access token to the container, because our access token can be exposed in our code. It should be embedded in the environment variable. So this command, it just read the access token from the access token.txt, and then it set the transformer access token to be equal to that token. And the last two steps, we need to expose our port 5000. We need to expose it. What does it mean to expose a port? Flask application run on port 5000. So we need to tell our image or our container that it's going to access the port 5000 of our local machine. And finally, we are going to set the entry point of our Flask application. Now I need to note what is the difference between CMD and run. When we say run, so this command is executed when we are building our image. But when we say CMD, it means that when you make a container from that image, it's going to run this command when it gets started. So when we are going to, while we are building our image, it's going to run all this command. It's going to run apt get update, apt get installed. It's going to run pip install requirement.txt. And now we have our image. When we make a container from that image, it's going to run this command. Okay. Now we are going to build all the image. So I'm going to show you. Now we have our Docker file. It's now done. And we need to, from this Docker file, we need to make an image. So how we can make this? We have this command. We just say docker build, and we add the flag of -t. It, to tell the name of that image, it's going to, for example, be app app test, for example, and we are going to make dot. What does dot mean? It means that it's going to search for any file called Docker file in the current directory, and it's going to build this file. But we need first to open our Docker desktop. This is the Docker daemon. We have here an error showing that the Docker daemon is not running. That the one we have explained in the slide before. So we need to run our Docker daemon by opening our Docker desktop, and it's now starting. Okay, now our Docker desktop or our Docker daemon has been started. Now we can start building our image. When we are building our image, now it has been built very quickly. Why? Because I have already built this image before, but if this is your first time, it's going to take some time because it reads all your layers from the cache. So if your cache already include a similar image, it's going to use it directly. So this is why it's done building immediately. After that, we have the image. So if we write docker image ps, docker image ls, okay, we now have all our image. I have so many images, but this is our image, my app. Sorry, it's app test. Okay, this is one that we have created. Now we want to take this Docker image and make a Docker container from that image. Why we need to make a Docker container? Because it's just an image, it's just a template or a blueprint. But we need a running instance from this image, so we are going to make a Docker container. To make a Docker container, we are going to write Docker. We need to run this image, so Docker run, okay? And we are going to expose our port. As I explained before, exposing our port is saying to that container that you are going to access port 5000 of your local host. And then we give it the number, the name of the image app test. Now our container is running. You can find here that this is our Flask app. We can test the Flask app from Postman by making the GET request to make sure that our Docker container is running and we can access its endpoint from any other application. So here we have, I'm going to call the endpoint of the GET. And now you can find that app is successfully running. It means that our Docker container is running. So now we want to stop our Docker container because we want to take this image that we have already did and push it to Docker Hub so that anyone can download this image and use it. So let's say Docker PS. Docker PS, it lists all the current containers that are running. So Docker PS, we have app.py. It's created about a minute. and it's running. So we need to say docker stop, and we can give the ID of the container to stop it, or you can give the name, but for simplicity, we are going to use the ID. It sometimes takes some time to stop. Okay, now it stopped. So we are going to take this image, Docker image ls. We are going to take the image that we did, which is called app test, and we are going to push it to Docker Hub. So we are going to say, first thing, we need to tag the image that we already did with a name. So we are going to give it a name, for example, Flask test. Okay. And we are going to push it to my Docker Hub. It's called Rofayda. And we are going to give it a name, Flask test. Okay. Sorry. It's app test. We give it the name of the image that we want to push. So app test. Okay. Now we have done with the tag, and we want to push this image. Docker push. Okay, it's now pushing. So if we open Docker Hub, okay. If you open Docker Hub, we have now the Flask test. It just pushed 1 minute ago. And if you want to pull this image, you can just write pull image and give it the name of this image. Okay. So this image has your Flask application, having also your model, your Flask model, your Gemma model. Now you want to run this container on the AI server or whatever server you want. But in this case, it's going to be a Liquid Galaxy AI server. You want to pull this image and run it on the server, and then access this image, this container or this running container from your Flutter application. So what I did is making an Azure server, okay? It's similar to the one in Liquid Galaxy, but it doesn't contain a GPU. So it's going to be, it's going to take some time to get the response from Gemma model. And I also, on this server, I have the container running. So if we write sudo docker ps, okay, I have here the Docker containing the Flask app and the Gemma model on my server. We need to start this container. So sudo docker start 676. Okay. And let's see. Now the Docker container is up. We have here the status. It's up 3 seconds ago. To make sure that it's running successfully, we can say sudo docker, and we say logs. It's going to display all the log of the Flask application and give it the ID, which is 676. And now we have our Docker container, and this is our logs. So we want to access this endpoint in our Flutter application. So let's open. Okay, I already did a small Flutter application to test the endpoint and see how we can access the container. Okay, let's open it in VS Code. Okay, you should all know that our container is now running on a server that has its own IP and it has the port 5000 exposed. And all you are going to do is taking this IP and the required endpoint and add it into your Flutter application. So here I have a function. Okay. This is the function for the call endpoint in a Flutter application that we need to send the text that you want your Gemma model to generate. To illustrate it more, I'm going to open it on BlueStack so you can see the application running and then see the code. Okay, sometime. Okay, I also want you. I want to show you on Postman that the container running on the server. You can send it a text at the endpoint called generate. Here we have the IP address of the server on port 5000 and with an endpoint generate. And we can send in the body anything you want to ask Gem about. So you can ask anything. I have asked maybe what do you know about what do you know about Flutter, for example? Okay, and we send. You should know that Gemma model takes so much time. If you are not running on the GPU, it may take up to 1 minute to respond. So we are going to wait until opening. Okay. Now it respond. It took 37 seconds to answer. It tells me that Flutter is an open source UI framework for the web, mobile, and desktop for the same code base. So it accessing the endpoint correctly using the IP of the server. Okay. Let's wait our Flutter app to open. For now, let's see the code. All I have did is a function, and this function send a post request for my server, which have this IP and this endpoint. This endpoint generate, and it sended the text that you are going to give it on the Flutter app. We can also test another thing on Postman. Maybe what is good about Docker. and send. It will also take some time to get a response. It's okay. Okay, let's open our application. Okay, one thing you can benefit from this Docker container, if you are on the server and you want to see all the requests that you got, you can simply say sudo docker logs and give it the name of the container, and you are going to display all the requests that has been done. This is the first request we have did, and this is the second one. And the time of the request, it's 5:20 and 5:22. And let's see the response. It say, what is good about Docker? This is a platform for developing, shipping, and running applications in containerized format. And it continues saying, you can also, in JAMA model, you can specify the length of the response. So here I have specified to be 50 to be quicker in the response. So let's test it on the Flutter application. And let's say what is good about any question about computer science. Okay, and call the endpoint. It will also take around 37 seconds to respond. So we are going to wait. And also, if you came here, you can see all the HTTP requests that has been done on the container. So let's wait. Okay, it got the response. It say what is good about computer science. Computer science skills are highly sought after in the job market, according to Bureau of Labor. So it's now responding, and the container on your server is running on your Flutter application by just a sample endpoint call to the server. So this is now we are done with the demo, and let's see the Q&A session. I think my laptop is freezing because it's running many. Okay. Okay, the Q&A session. If anyone have any question, leave it on the YouTube chat.
Thank you, Rofayda. It's a typical situation. Laptops, unless you have a very powerful machine, too many applications running simultaneously, and eating memory and CPU.
Yes.
And also, you said that you don't have a GPU, so even worse. But you did it very nice. Let's see if our colleagues from the YouTube chat have any question. In the meantime, could you please stop sharing your screen slides?
Okay.
Okay. Let me see if I change this to here. Good. So, Rofayda, let's wait for any question. Thank you for your presentation. It's been half an hour. at some point, I understand sharing the different screens with a laptop with only one. You only have one screen. It's difficult to try this. This is the reason the guys were saying that what you were talking about were not shown on the screen, but you did it well. Repair it. So YouTube people, any questions for Rofayda? So it's 16:30. I don't remember what UTC is now. UTC over. UTC time. We are just half an hour to start the GSoC real thing. Half an hour.
Yes.
So we just end this presentation, and then you can go and crash their application. It happens suddenly. All the students, the contributors, when they start to push, register, uploading their application proposal. In the meantime, and again, I say this an hour ago in the Discord, but the point is the following: we as Liquid Galaxy project have our own rules, but remember, you have to be on the Google server, Google platform, and they have, I will say, their own rules. Those are the ones that manage, or rules are under the GSoC rules are compatible. But if they say you have to upload your proposal in PDF or in whatever, or in draft mode or in whatever, because every year they change the way they do the things. Sometimes they change it, and to be true, I personally as administrator, I cannot not see that changes, because I have not the same role as you. There are roles for administrators, for mentors, and for contributors, and every have a different screen. So I can see. I don't know exactly how will be the registering protocol for you on the GSoC, but read carefully their text, how to do it. It will be not as much difficult. You just have to go there and register your name, your few data, and then upload the proposal in the way they say. This way we will have it in our. We can access your proposal in the GSoC platform and start the next step. So, Rofayda, there is no more questions. So we are going to end this streaming. Thank you very much for your presentation today. It's been nice. And I think plenty of people will use it, because many contributors are thinking to do projects using these technologies, and everyone needs to run their application on the Docker server if it's AI based. So thank you, Rofayda, and see you soon. Okay? Bye-bye. Take care. Bye.